Hello students. Today we are going to solve a question from optics, and this question basically asked in TIFR 2019. So in that question, there is a double slit diffraction. And for this experiment, there is a laser source that is used. The wavelength of this laser source that is given. That is basically 1.2 micrometer. Also, the separation between slit and screen that is provided, that value. Separation between slit and screen given as 1.8 meter. Further, they have given that diffraction pattern. So diffraction pattern they have obtained like this. There is a central bright, and these are basically what? These are basically primary maxima. This side also you have a primary maxima like this. Okay. This separation is given, distance between this point and this point, that is given 0.6 centimeter. Okay. So what you have to calculate? You have to calculate slit separation, that is D, that you have to calculate. That is the question. Okay. So let us solve this question. We can notice from here, from this spectrum, we can calculate the distance of first primary minima. So that distance will be how much? Distance of first primary minima, that is noted as y. So that will be the distance from central bright. So if this distance is 0.6 centimeter, obviously this distance from central bright to that of first primary minima, that we can calculate y will be how much? Half of this value. So it will be simply 0.3 centimeter. Now I use that condition of primary minima. So that is nothing but a sine theta, that should be equals to how much? N lambda. And for first primary minima, this is first primary minima. So for first primary minima, N will be how much? That will be 1. So it will be simply lambda. Okay. Now we know sine theta is nothing but y by d. And that should be equals to how much? Lambda. From here I'll get that value of A. A is basically what? A is basically slit width. Okay. And that should be equals to d lambda by y. Okay. And d is given, that is 1.8 meter. Lambda is 1.2 micrometer. So it will be 1.2 into 10 to the power minus 6 in meter. And y is given, that is what? Y is, so we have calculated 0.3 centimeter. So it will be 0.3 into 10 to the power minus 2 meter. Okay. So if you calculate that value of A, you'll basically get 0.72 in millimeter. Okay. But we have to calculate slit separation D. So to calculate this slit separation, we'll use that concept of missing order. Now we can notice this is the central bright, and for that n value will be how much? 0. And this is the first order, n equals to 1, second order, n equals to 2, third order, fourth order, fifth order, sixth order, sixth order, right? So basically this order was missing in that question, seventh order, right? 1, 2, 3, 4, 5, 6. Seventh order was missing. Okay. So if 7 order is missing, that corresponds to what? That corresponds to m equals to 1. Because of this primary minima, that n equals to 7 order maxima was missing. So I'll use that condition of missing order, and that is basically d by a. That should be equals to how much? D by a, that should be equals to n by m. So which order was missing? 1, 2, 3, 4, 5, 6, 7 order was missing. So n will be how much? 7. And that is because of first primary minima, m is 1. Okay, so this is basically 7. So from here I'll get the value of D, and that should be equals to 7 into A. Okay, we have calculated that value of A, that is 0.72 millimeter. So D should be 7 into A, and that is basically 5.04 millimeter. Okay, so this is the separation between two slits. Okay, thank you.